Hi, welcome back to my electrical science channel, and as promised last time we said when we calculated the resistance of a circuit that next time we'd look at how voltages and currents are shared around it. So that's what we're going to do today. So we're using Ohm's law again, and what we can see is that the resistance of this circuit is 6.16 ohms. Now, with that in mind, we know a voltage here of 5 volts, and so we can work out the current through the 2 ohm resistor. So we can say I is equal to V over R. So I is going to equal 5 volts divided by the whole of the circuit resistance, because that current will travel up through here. You get the whole of the circuit current here, and then it'll split up through that network. So V over R, we know that R is 6.16 ohms. So the current is going to equal 5 divided by 6.16. So that is 0.81 of an amp. Okay, so now we know the current through it, we can calculate the volt drop across it. So V is equal to I times R. So V is equal to the 0.81 times the resistance, which is 2, so V is going to equal 1 times 2, and that equals 1.62 volts. So it's 1.62 volts. So we can now say 1.62 volts is dropped across there. So we can say that the voltage across the parallel section there is going to be that, which is 5 volts, subtract the voltage just dropped across there, which is 1.62, and that's going to equal 5 minus 1.62, that's going to equal 3.38. So that's 3.38 volts across there. So now we know that, we can work out the current through each of these resistors. So the current I is going to equal, so we'll say the 7 ohm resistor first. So current, so rubbish ohms. So 7 ohm resistor. The current through that, I, is going to equal V divided by R. So the current there, I, is going to equal the voltage, 3.38, divided by the resistance, which is 7. So the current there is going to equal 3.38 divided by 7, and that'll equal 0.48 amps. And now the current through the 10 ohm resistor. Once again, we say I is equal to V over R. So I is going to equal 3.38 divided by the resistor, which is 10. So the current I is going to equal 3.38 divided by 10 is equal to 0.33. And we should find then that that plus that is going to equal the total current there, because the current is just being split up. So that one plus that one must equal that one. So if we try and prove that, we can say 0.48 plus 0.33 equals 0.81. So there's the proof. So these are those two currents, that 0.48 plus 0.33 is equal to 0.81 amps, which is exactly the same as we calculated there. So you can see here that current splits in two, and that's how the voltage and current are shared across a series parallel network. Right, last time I gave you another circuit like this to calculate the total resistance on, and we come up with the total resistance being 19.28 ohms. So what I want you to do now is, if you calculate the currents and the voltages and how they shared in this circuit, then if you pause and then I'll go over it. So you try it for yourself and then run it to make sure you've got it correct. So we're saying that there's 12 volts and 19.28 ohms on this network of 5 ohms, 25 ohms and 30 ohms. Pause now and then I'll work it out for you just to make sure you've got it correct. Okay, so if we look at this then, we've said that the total circuit resistance is 19.28. So to work out the current at this point, the main circuit current, I, is equal to V divided by R, volts over resistance. So I is going to equal 12 divided by 19.28. So I, the current, is going to be and that's going to be 0.62 amps. So we can say that with this voltage and our resistance at this point, and hitting this resistor and running through this resistor is going to be 0.62. So then we can say what the voltage is across there. So V is equal to I times R. So V is equal to 0.62 times the 5 ohm resistance times 5. So V is equal to I equals 3.1. You can see now this is like being electrical detectives. We're using clues from previous calculations so we can work out the next one. So now we've said that there's 0.62 amps there, and we get a volt drop of 3.1 volts there. So in our electrical detective work, we can say that the volt drop across here now is going to be 12. Subtract 3.1 volts. So 12 subtracted from 12, subtract 3.1, and that's going to equal 8.9 volts. So there's going to be 8.9 volts to drive the current through here. So if we want to examine now how much current is flowing through each resistor, we'll have a look at the 25 ohm first. So we'll say 25 ohm resistor. I is equal to V divided by R. So I is going to be 8.9 divided by 25. So I is equal to 8.9 divided by 25, and that equals 0.35 of an amp. And then we can look at the 30 ohm. Excuse my threes. So once again, from Ohm's law, I is equal to V divided by R. So I is equal to the voltage, 3.1. So so I is equal to V over R. So I is going to be the voltage, which equals 8.9 divided by 30 ohms. So I is going to equal that equals 0.29 of an amp. So to prove then that these two is the same as that one split up, we can say that 0.29 plus 0.35 equals 0.29 plus 0.35, that equals 0.64. 0.64 amps. So that is pretty much that. There's a little bit of a tiny bit of a difference, and that is due to rounding error, and that's all. It's just rounding up as we've done this calculation. So that is how you work out how voltages and currents are shared in series parallel networks. Hope you enjoyed that. Please like, comment, subscribe, and anything I can help you with, please say it in your comments, and I'll see if I can add it for you. Thanks. Have a good one.